go home and watch it again. Okay, so in your R Cloud, I'm not sure about the one that you download because it's need a tiny text to compile the PDF. I have it in my computer, but I can't help you if I'm not with you. So what you're gonna do is you're gonna go here under File, a little plus here, and R Markdown, and it'll ask you a question. Right? Title, maybe extra credit, something, whatever you want to say, extra credit. Author, your name, right? Make sure you put your last name as well. Date, it's gonna be PDF. Don't do HTML. You cannot upload on Google. And press and this document, yeah, you're good. Press OK. Now it's gonna give you a default. You see this? This is default. Just let's run it. Let's knit it. You press knit, and you have to name it too. You have to name. This is MCAR data. So you can name anything you want. Just say extra credit. Oh, extra credit. Make sure when you name it, no space. If you have to do space, use underscore or just use upper letter E and upper letter C, but no space. R doesn't like that. It's not like it doesn't work, but sometimes it's make it complicated. And make sure you remember where you save it. I recommend you create a folder in the beginning. Name the folder. Everything you do about this data set, put in that folder. Your data set, your R, your picture, whatever that you're gonna use, right? Say I'm gonna make a folder, say extra credit EC. I have no idea where it's this computer. I can't. I don't know where I'm at right now, but I'm just gonna save it. And then it's gonna compile. Oh, make it bigger. Right there. It's compile. See, maybe extra credit. And because it's default, you have this. You delete it. And what you can do is you're gonna delete from this point down. Nothing. If I compile it, where is it? Where's my right here? See, nothing. Oh, I thought I compiled it. Something wrong? Required tiny text. Oh, come on. Let me see what it say. Then if you are not sure, install. Annoying. I can do it on my computer. Share to you. I just what? Oh, so sorry. Yeah, thank you. Yeah, I'll share my screen from here. So give me a second. Yes. Huh? Yeah, I'm recording it, but I'm gonna stop recording. All right. Sharing my right now. Right. Okay, so R Markdown. I'm lazy now that I still want to type too much. There you go. Right. And then if I need it, it's gonna ask me to save. So for me, it's document academic OU stat 2220. And then I'm gonna make a folder here. I'm gonna call R. You can call it anything you want. And then say save as EC credit. Any name you want, okay, just no space. It's 86%. Come on. Right there is having output. This is output, right? This is the default. Now, if I delete all these, I don't want it. And I'm gonna knit again. The little red thing here is running. See, nothing, right? Just the title, easy, right? So you can put sentence. You can copy and paste sentence here, right? So copy and paste sentence here. So number one, German example mean. You don't have to type. Sometimes you can just copy and paste. Data, right? Now, and you don't want to do by hand. You want to do by say you want to do by R. So if on the Mac is Command Option I have that Command Option and letter I on Mac. Does anyone use? If you don't have that, you just do by hand. Okay, you do by hand. Just do by hand. Just use it 3 times, and then use an R. And then down here another 3. But usually Command Option I. And then say, I am gonna import a data set. Do you guys know how to import? History, connection, environment. Right here, I think right here. Right here. And if I use Excel, browse. I don't have my data set here in the R, but I'm gonna use different one. It's this lecture, chapter 3. Do I have some? Chapter 2, right here, chapter 2, I have some. I'm just gonna pick one, okay? I suggest you move the data set into your folder, the R folder. Trouble. Open. Don't do anything else. Let it run its course and then import. Right there. The data set, right? Okay, so up here, if I was you, I'm gonna copy this part to here. And I'm gonna name it. I'm gonna name it something different. Say travel. Right? And then if I'm gonna remove that little thing, and then if you do Command Enter, is run. Pattern not exist. I guess I have to. Copy, go to R. No, R. Come on. R. I'm gonna say travel. Travel. All right, go back. One more thing I would do is go to File and go to More, Set Directory, Set Working Directory. So it's always there. I'm gonna copy that and put down here. So when I run it, it's know where I'm at. Change. Okay, it worked. All right, so now I'm gonna view travel. View travel. Yeah, it worked, right? Now I'm gonna do the mean. I'm gonna mute the view. I don't want it. So I'm gonna do the mean travel. Now the 2 column. What column you want? You want the minutes column, right? So the dollar sign tell you which column you want. Then run Command Enter. Right there, 25.33. Right. I'm gonna knit to see what happens. Knit PDF. Error in travel could not find function. Come. I just did the mean. Oh, my bad. I gotta go to Document, academic. OU. Oh, okay. All right. Now I'm gonna do it again. Sorry, I did the working directory wrong. So right there. Now it's correct. This one right here. Delete that. Okay. How come? Trouble. Right here. XLS. And I can do it from here. I can run it from here. How come I cannot knit it right here? That's ridiculous. Document. Okay, I'm gonna see what happened. It worked from here, but it won't let me knit. I see why. I have to call the package re-XL. There you go. Can you guys see? Look what you're gonna see. So you keep doing it. The next question, you copy and paste on my thing, and you keep making a little code chunk. It'll show up. If you can't do it, it's fine. Use a Google Sheet. All right. All right. Okay. Yes. Okay, I can do that. Yeah. But again, if you still cannot follow it, it's not a problem. It's optional. But basically, in order to have the code chunk, you have to have this a little chunk first. Control, Command, Option I. Right? Okay, chapter 16 is short. It's only 15 slides, I believe. Duplicate. I use that to make your slides. What do you use right now? Okay. Can someone remind me what is statistical inference mean? From the previous slides. What statistical inference mean? If I say I want to do a statistical inference on this data, what do I mean by that? I should put a quiz. It means I want to use the sample data to infer about the population, right? Because a lot of time I don't know about what I can't have a. It's impossible to do collect all the population data point, right? So what you do is you just try to pick it out, sample from the population. I think they do poll, right? Every year they do poll about presidential election. They want to know how many percent people want to vote for Democrat, or how many percent want to vote for Republican, and others, etc. So they do poll. So they use poll to infer about the population who's going to vote for the blue or who's going to vote for the red. Now, there are two ways of doing this. One is using confidence intervals, and the other one is using hypothesis test. In the textbook, they use test of significance. It sounds fancy to me. I like it. So I'm just going to say hypothesis test. It's the same thing. All right. BMI is the body mass index. You calculate BMI by taking your weight in kilogram and divided by square of your height in meter. That's why the unit is kilogram per meter square. So if you are if your BMI is less than 18.5, you are considered underweight. If you are over 25 kilograms per meter square, you may be a little bit overweight. The mean BMI of these 936 men was 27.2, and the sample standard deviation is 11.6. on the basic of this sample, we want to estimate the mean BMI mu in the population of all 23.2 million Americans, right? It doesn't make sense to ask about their BMI of all 23.2 million, right? Use the sample data. Okay, here's the reasoning of statistical estimation. We want to know how accurate X bar to estimate mu. Right. So there's several ways to do this. One is you can increase your sample size, right? But that's sometimes it costs a lot of money. 23.2 million. How big enough? How big my sample size I can do? I don't know, right? The other way is you can do repetition. Just keep picking 936 people from the population, right? So that's a bit better because I don't know how large should I go to estimate the 23 million people. But what I can do is I can keep picking the same sample size from that population, which is 936. And then I'm going to compute a bunch of X bar. And then I'm going to graph it, right? Because what we've been doing. Now X bar, because the sample size is so large, 6, definitely bigger than 25, it's approximately normal. And what kind of rule? What kind of rule that we have this? I'm going to ask you a little question, see if you understand. How come I can have this? How come I can say that X bar is approximately normal? Mu and sigma divided by square root of n. What rule allow me to do that? CLT, right? Central limit theorem. Because in the beginning, did it say anything about the normal? No, it is not saying anything about normal, right? So I don't know whether it's normal or not, but however, my sample size is huge. So because of CLT, that's happened. Can you calculate sigma? Can you calculate the standard deviation? Sigma is 11.6, right? And the square of n is 936. I don't think it's 0.4, but 11.6 divided by SQRT of 936. I don't have my calculator with me. Do this. 0.379. .379. Now, because I want to use the empirical rule, right now we try to construct a confidence interval from the scratch. Later, I'm going to show you the formula. Right? Just use the formula. But right now, from the scratch. Now, from the scratch, I don't know what 0.372 0.379 is. I don't know how many standard deviation from the mean, right? But if I can round it up to 0.4, so I'm just gonna say 0.4 is 1 standard deviation from the mean, right? Then 2 standard deviation from the mean from both sides will be 0.8. Now what I'm gonna do is I'm gonna take X bar minus 0.8 and X bar plus 0.8. So this is imply X bar minus 2 times the standard deviation to X bar plus 2 times standard deviation okay, so what you get? X bar is 11, X bar is 27.2 minus 2 times 0.4, right? Which is 0.8 right there, to 27.2 plus 2 times 0.4. 0.8, 28, 20 minus 0.8, 26.4, and then the other one would be 28. Okay, so that's my confident interval. And what I'm gonna say that because standard deviation from the mean is how much percentage of the normal curve? 95, right? So I am 95% confident that my population mean is somewhere between these two values. I don't know where, but I know that it is. I'm 95% confident that it's between those two values. Right? So it's called wiggle room. You kind of give a little range, and then you tell people the population mean is in there. Okay? So the interval is from 26.4 to 28. Oh, I'm gonna give you a little break. You guys look tired. But let's finish this slide first, and then we'll do a break. Capture the population mean. So the interval is from 26.4 to 28. Capture the population mean for all 95% of all possible samples. We say that 95% confident that the mean BMI mu of all young men is in some value is between the interval 26.4 to 28. Let's take a little break. You guys look tired. All right, so next problem, SAT. You guys take SAT to go to college? ACT. I guess they abandoned SAT now, right? Yeah. ACT. That's what my other students say. I don't know. I'm from Vietnam, so we don't take those. We take different things. Yes, we have that. We have two actually. So when you finish 12th grade, you take a general test, and when you pass that test, you graduate. If you don't pass, you take the 12th grade again. But usually the easy, it's not too bad. Like 90% people will pass, unless you don't study at all. And then when you want to go to university, you have to take their test or national test. Yeah, and that's harder, much harder. Depend what program. Like medical is very hard. Engineer is hard. If you fail, you wait till next year. And I think you have 3 chances in Vietnam. I don't know about China and Korea. Vietnam not too bad. Chinese, Korean, Japan is bad. When we go to the season of national tests, suicide rate go up. It's family pressure, but not in Vietnam. I don't see that. But I think in China and Korea, especially China, the population is huge. Competition is difficult, right? They have a lot of people, so I guess their test is harder. Okay, I think I would fail if I take that test. I never like it. Let me have to. All right, so for this problem, the SAT, we take a random sample of 400 high school senior, gain an average of X bar is 40 points in the second attempts. So they let you retake it. Assume that the change in score has a normal distribution of a standard deviation is sigma equal 25. When they say the mean change, the change in score. So say Rami take the first time, and then you like take another time, right? And then you subtract the 2. So that's the change in score. We want to estimate the mean change in score mu in the population of all high school seniors. So let me highlight something here. We need to understand the problem before we actually answer the question. So this right here, if I call mu1 is your first attempt taking SAT, your first score, and then mu2 is your second attempt, the second score. Mu1 minus mu2, I want to estimate that. Right? All right, give 95% confident interval. Well, 95%, that's 2 standard deviation. By the way, this we assume it's normal, it's perfectly normal. Like in real life, it's not. But because we don't know the formula, we can assume that it's a perfectly normal distribution. 95% confident interval means how many standard deviation away from the mean? Yeah, I mean standard deviation equal 2, right? So 95 confident interval, remember X bar minus 2 times standard deviation, and X bar plus 2 times standard deviation. Right? So this one X bar is 40 minus 2 times 25, and then 40 plus 2 times 25. 40 minus 50 is negative 10. 40 plus 50 is 90. Wow, that's a very large. The range is huge. What's negative 10 tell you? What's the negative 10 tell you?
It did worse.
Yeah, it works, right? It works. Too bad. So number 2, based on your confidence interval in part A or part 1, how certain are you that the mean change in score mu in the population of all high school seniors is greater than 0? Based on your confidence interval, are you certain that the mean change score is the positive value? Okay, well, you can do that. You can say that, okay, from negative 10 to 0, that's negative, right? From 0 to 90, that's positive. But are you certain that all the mean change in all mean score is greater than 0? No, right? Because what do I say? We say that I capture the mu, but I didn't say where, right? I know that it's between these two values, but I cannot pin down where. Right? It could be 10 towards the negative 10, it could be negative 8, negative 4, right? Or it could be 10 towards the positive. Hopefully 10 towards positive, but I don't know where. If I just eyeball the confidence interval, so we say no. We can't be certain that the mean change in score mu in, I gotta say it all out, in the population, this is called context, population of all high school senior is greater than 0 because we only we only 95%. I don't want to say it. We only I'll say it. We only be certain about the fact that we capture the mean score, the mean change mean score, the mu, but we can't pin down exactly the value. It could be negative for all we know, right? You know, I want to put something more, because right here, right before, since the confidence interval CI contain negative number or negative value, yeah, and then we can only, yeah. So again, confidence interval only tell you that the mean is somewhere between the two numbers, but you don't know where. The population mean. Now I can tell the X bar. I'm pretty sure X bar is going to be positive because X bar is just going to be average of 2. If the 10 plus 90 plus 80 divided by 2 is 40. So X bar is positive, but mu not sure. Okay, so let me remind you what we did. I got X bar minus plus minus 2 times sigma. I don't want to say 2, I'm going to say n, where n could be 1, 2, or 3. Remember, 1 standard deviation from the mean, 2 standard deviation from the mean, or 3 standard deviation from the mean, right? Your X bar, that's this right here. That's your sample statistic, right? And then n times sigma. I don't want to say sigma, and maybe I'll say standard deviation. That's your marginal error. So margin of error, that's your wiggle room. Like instead of just doing X bar, you add a little bit more, a little bit less to create a range. Wiggle room. I will explain about the confidence level later. This part right here later. Okay. So this problem, let's do it real quick. Because I want to jump to the next one. Mental, physical health. Read it. Actually, I want you guys to compute it and then maybe put it in the chat for me privately. I got this one from the book. I don't like it. I'll tell you why. It confused me. But the only reason I include it because I'm afraid you might see it on the homework. So at least I cover. But I don't like it. Check. Oh, yeah, that's what I told you. Okay, what you guys have? Let's see. See how much you understand. If you can do this one, then you really understand. Oh, nobody. Oh my God. I don't blame you. I tell you what, I don't like it. Okay. So the formula is sample statistic plus or minus margin of error. I have margin of error, which is okay, right? Yeah, I have margin of error, which is 2. Well, what's my sample statistic? Read the first sentence. 46%. You think 46% that's parameter or statistic? Come from a poll. Statistic, right? Come from a poll. Now when I say oops, sorry. When I say sample statistic, I don't always have to mean X bar. It could be what? It could be S, it could be S squared, right? It could be P hat. Remember P hat, sample proportion? I kind of mentioned it before. So this guy is P hat. That's why I don't like it. I don't know why they even put it here. So that's my P hat, sample statistics will be 46% plus minus 2. So that'll be what? 46 minus 2 is 44. 46 plus 2 is 48. That's why I say it confuse you. Instead of trying to look for X bar, which you can't find, it gives you P hat. It's another sample statistic. But I just kind of covered to ensure, in case you have it on your homework. What does it mean to have 95% confidence interval? Okay, so this one tell you to give interpretation. You probably gonna, I guarantee you have this on your exam. Interpretation of the confidence interval. So we always start out, we are 95% confident. It could be 90%, 99%. Doesn't have to be 95 all the time, right? In this case, 95% confident that we are not that the true mean or true here was a true percentage points no true percentage point what is the context of the points of adult 18 plus 18 and older set of their mental and physical health are good is between the value between I just say between 44 and 48. And I'll tell you what you, so the generic is, I'm gonna highlight in yellow or maybe in green. I'll highlight in green the generic. We are 95% confident that the true something, true mean, right? A lot of times we're gonna say true mean. And then the yellow is gonna be context. Context is problem, whatever it is, right? And is between, and again, 44 and 48, that's your context, depending on what value you have. I don't want to hear 95% chance. That's not true. I don't want to hear 95% probability. 95% confidence. Oh goodness, I was thinking I didn't record it. I did. Okay, yay! Here is your formula. You have to start from scratch anymore. Here's your formula. X bar with your sample statistic times a plus minus the margin of error. The margin of error compose what? The Z star, remember the 2 times 2, so Z star, instead of 2 is going to be something different now. Why? Because your population not always perfectly normal, right? Sometimes it's slightly skewed. So Z star going to change. It's not always 2, it's not always 3. Times sigma divided by square root of n. Sigma divided by square root of n, code is so people here, is your no standard error. Basically, that's your sample standard deviation. Okay, that's a little s. Maybe I'll write it here. No standard sound fancy. Another word, aka sample standard deviation. There are 3 types, there are 4 types. Population standard deviation, sample standard deviation, which is no standard error, and their standard error. There's 3 different things. Yes. X bar is your sample statistic. Like from the example, like what numbers? From the example is p hat is your sample statistic. And then because they give you the margin of error, so I cannot tell you which is which. It just say margin error. There's no the Z star and then the sigma divided by square root of n is including the number 2. So I don't know. But maybe I'll tell you the next example. I'll be able to tell you. Or you be able to tell me? Just eyeball it to tell me what number is which. Okay, confidence interval, these are the most common one. Now you say that Mimi, 95%, can I just YouTube? No, you cannot. Remember, data is not always perfect, legally normal, right? It's gonna be changes a little bit. Therefore, you have this. So these are a common one. I recommend you memorize them. If you can't, it's fine. You can always look it up. You're allowed to use the T table, the table. So on your car, on your table card, you want to look for Z stars. Make sure you look for Z star, not Z, not T, Z star. It's very difficult to, it's kind of difficult. It's kind of isolated in the bottom. So make sure you carefully when you look up the values. But on the exam, I only use one of these three. I don't know about the homework, but exam always all of these three. I never go outside of that. So far, so good. All right. Okay, this problem. Well, this is a good problem. I like this problem. Well, maybe, yeah, kind of. Still, I don't like when it say percentage. It's kind of confusing. If you click on that data, you should be able to access your Google Sheet, my Google Sheet. Now you have to copy and make it your own, okay? Because I didn't allow you to edit. For me, I'm just gonna go to my account. Delete that. Okay, but first, before we actually calculate something, I want you to tell me about the context. Sorry. What is the population mean here? What is the context? What is the context of the population mean? Read the problem, you tell me. What population mean describe? Anyone? Go ahead, Rami.
The average is or the letter represents the behaviors or increase.
Just say the in context is mu represent the population average of percentage, right? Percentage. I will ask you this on the exam. Tell me what is mu? What is maybe just what is mu? I don't know. A percentage tip from a arbitrary restaurant. A restaurant. They didn't tell me which restaurant, which I don't like. I like to know where they're from. Just an arbitrary restaurant. And then what's X bar? You only change one word. Instead of population, you change to sample, right? And then sample average of percentage from the restaurant. There are two assumptions. In order to do something, there are two assumptions. First, your sample should be a simple random sample. You don't have to prove this. It's gonna be included in the problem. I'll never ask you to prove this. Include in the question. Okay. Always simple random sample. I mean, not biased. The normal model of the response. So when you plot a bunch of X bar, mean percentage tips, the normal model of the response should be normal model response of percentage tip this one either your population, if your population is normally distributed, you okay? If it not, if it doesn't say anything, does it say anything about more normality here? No, right? So I have a problem now. Then you're gonna use CLT. But wait a minute, is CLT, however, how many data points you have here? 20, right? Not 25. So what I'm gonna do, my last chain, I'm gonna try to graph it because I have data point. I'm gonna graph it. Now, hypothetically, if you don't have the data point and I ask you to proceed, what I'm asking you, what are you gonna just say? Can't proceed, right? Can't proceed. But because I have data point, I'm allowed to graph it. So highlight it, and then I think format or insert. I'm sorry, insert. Let me share my screen so people from home can see it. Am I sharing my screen? Okay, thank you, Anthony. So highlight it. I can't tell. Oh, darn it. How do I go back? Control V. There. And then insert, and then charge. I don't want scatter. I want histogram. Right here, histogram chart. It looks somewhat normal. Not too bad. It's kind of right skew, but it's somewhat normal. It maybe I have another bin here. Maybe instead of 1, 2, 3, 4 bin, I have 5 bin. Maybe a little bit better. So it's somewhat normal. So yay. What does the sample mean? Do you guys remember how to do sample mean? Yeah. Thank you. Equal average. And then just highlight the range. 22.21. No, I'll tell you the standard deviation. I'll tell you how to calculate standard deviation as well. Okay. We have the data points. So actually, I give it to you too. Oh, okay, then you can use it. Yes, I thought if they don't give it to you, then you have to use the data points. But they give it to you, so it's good. Okay, so sample mean here is, I forgot, what was it, 22.21? You can do by hand, add them up, divide it by 20, right? Not too bad. All right, create. I want you to create the 95% confidence interval. I'll walk around, see how you do. Maybe put it in the chat. Yeah, you go ahead and put in the chat. Let me remind you the formula. What's the formula? Try something else. Hypothetically, if I don't give you the standard deviation, you can calculate from here, right? 1.96, so roughly 2. Just use the STDEV. But it's given, so you're okay. Yes. Oh, I have my calculator. For people from Zoom, if you want to pick up your exam, just come to the class, okay? Maybe next time when you come for the quiz. Just remind me so I don't forget, right?
Sure.
Let's see, Rami. I think Kai got the same thing. Anyone have the same answer? Yeah, you got the same. Okay, good. Mhm. So X bar is 22.21 plus minus Z star is 95%, 95%, so 1.96. Let me highlight something here, maybe in yellow. 1.96 Z star. And then the sigma they given is 2. If you don't have sigma divided by square root of 20, right? So this one equal I got 21.33. And then that's my lower bound, my upper bound. 23.09. Okay, that's your CI. Write the sentence that interpreted the interval in context. Do you guys want to give it a shot? Yeah, yes. Oh, yes, you can use your calculator. Yeah. You always allowed to use calculator. Yeah. And sometimes I'm gonna allow you to use computer as well for the binomial. I think this exam, I'm gonna ask you to use computer as well, okay? You just have to turn around so you can see. But you always allowed to use calculator. Write a sentence that interpreted the interval in context. Anyone to give it a try? That the to the publishing average of percentage, right? That's why I have this here. Like you don't have to look up, right? You already have it here. Just copy and paste. Is what is between. Yeah, that's it. That's it. So we are 95% confident. Again, it's not always 95%. Okay, depend on what I give you. Confident that the true average, population average, same thing. True average of percentage tip from a restaurant is between 21.33 and 23.09. Simple. Now, confidence level. Let me go back up here. I said that I'm going to come back to the confidence level. Confidence level is not, it's not the same thing as confidence interval. So confidence interval, confidence level is not the same as confidence interval. Confidence level mean, let me go back up here, is that the proportion of times this method will produce an interval that contains the two parameter values. So for example, if I repeat the process 100 times, if I'm 95% confident, then I'm saying that 95%, 95 out of 100 times that I compute my confidence interval, 95 out of 100 of those confidence intervals going to contain my field. That's what I mean. Okay? So let me give you the interpretation in context for this problem. So I'm going to use blue, green. If the procedure was to repeat it many times over and over again, we are again, then 95% of the resulting confidence interval plurals will contain the true average. Now it's context, the true average representative from a restaurant. Can someone tell me what's the difference between it? Just like eyeballing. What's the difference between confidence interval and confidence level? By just eyeballing the two interpretations, the blue and the green. What's the first thing you see the difference? You don't have to understand it, but the first difference you see is
like you know that you're 95% that it's between a certain spot while the other ones like you repeat it multiple times, you're 95%
Good.
sure you'll have that.
okay. I think I get you. Yeah, I think yes. So the first one is one confidence interval, but only one time. The second time is many of them, right? And then 95% confidence level means I'm gonna keep doing it over and over again, and 95% of my resulting confidence interval will have the mu in between. That's why we don't include the confidence interval in the confidence level, because there's too many of them. I want just one particular confidence interval. Okay, all right, it's good. Google Sheet to check. We don't have to do that. I just do it with R. Yay! Last slide. Last slide is an important slide. It's about the trade-off between confidence level and the marginal error. Let me ask you one more question above here. Instead of asking you to create a 95% confidence interval, if I would have asked you to create a 99% confidence interval, is the confidence interval is going to be wider or narrow? Instead of 95, I'm going to do 99%. Wider or
Wider.
because
More range of error.
okay.
The 95, which is only like 95.
Okay, I think you use empirical rule. But I want you to use the formula here in the black.
Would you just have a larger value?
Yeah, Z star bigger, right? So X plus something bigger, X minus something bigger, the range is wider. So remember that. Now high confidence levels say that the method always gives the correct answer. You give them more range, right? That means the probability that your mu gonna be in there is greater. Right? Smaller margin error say that you pin down the parameter quite precisely. So let me remind you, what is the margin error? This part right here. This slide, only one slide, but it's important slides. Can I denote margin error M? I don't want to write out. Now the margin of error is determined the width of the confidence interval. Nothing you can do about X bar. It's the nature of your data set. But you can change this. What do I put here? Now, what happened if, so this imply if my marginal error M is small, if the marginal error is small, if this is small, then you have a narrow confidence interval, right? CI becomes smaller. If M is big, then CI is wider or bigger. Wider, narrower. Right. So what I put in here. Okay. The two ways you can do this. If you want a small confidence interval, you better have a small margin of error. But if you have a small margin of error, what has to be compromised? Z star, right? Z star has to be smaller. So if Z star is smaller, if you have a lower confidence level, if a confidence interval, then the method does not give you the good answer that you want, right? So small CIs. Imply you have to have either smaller Z star, but smaller Z star is not good. We want high Z star. Mean higher confidence. So this is a trade-off. So this right here is the trade-off. Smaller confidence, smaller margin error, but at the same time you have a smaller confidence interval. So probability that you want to be there is smaller. Or what you can do, how can minimize the margin error? You can increase the sample size, right? You can make the n bigger than fraction smaller, so the current interval is narrower. Or you can increase. Nothing you can do about sigma. Sigma is the nature from the data set, right? You cannot. Is be costly sometimes. So we can sometimes we can't afford it. Right? They have fund. Okay, so that's it. That's the argument between confidence interval and margin error in the Z star. You try to find the sweet spot, the optimal spot. I'm going to return the exam to you. Next week we have the quiz, right? Whatever the quiz.